Hello everybody. This video is the second video that I'm going to do on the communications daughter board, and today we're going to focus on the receiver. So let's get started. So as a general overview, first of all, I'm on the schematic, which is on dot project, and also we're now putting it on Subversion. And it's called the C-D, or the Communications Daughter Board. So let's get started. And we're going to deal today with the receiver portion, and this is the low-speed receiver. So we get started. The signal comes in right here. This is the antenna jack, and this is, of course, on a frequency of 145.825 megahertz. Alright, this device is a switch. It's an RF switch, and it's a single pole double throw switch, and it can be modeled as just a plain old switch. So in the receive mode, this line right here is high, and this line is low, and these signals need to be orthogonal. And it's actually controlled. This thing is controlled via logic from the push-to-talk signal. So when the push-to-talk signal is low, this switch is in this position, and the RF signal proceeds through this switch, through this DC blocking capacitor, and into the receiver module. So this receiver receives this signal and puts out a couple of signals. And let me blow this thing up a little bit so we can talk about these signals that come out. So let me gain control of my mouse and move this thing over to center and kind of blow it up a little bit. And let me get control of the pin again. So the signal comes in here and gets decoded. Well, of course, this signal is 145.825 megahertz. Out here is the audio output. So this is an analog output. Anything that gets on this receiver comes out this port on pin 7, and it's called receive out over here. That's one of the signals that come out. One of the other signals that come out is the RSSI, which is the Received Signal Strength Indicator, which comes out here. And this is, again, an analog signal that is proportional to the input of the RF. So, and that is this signal here. So, the stronger the signal, the more millivolts we'll have here. This goes to the analog to digital converter on the CDH board. So this piece of the schematic is very simple. Let me also give you some commentary and some color about schematics. As designers, you want to get very comfortable with schematic diagrams. I notice in the lab that most of you guys prefer looking at the physical layout, and the physical layout is way too complicated to comprehend. But fortunately enough, we have schematics, and you need to be very comfortable with schematics. Now, part of understanding schematics is what goes on in these boxes. Now, let me shift out a little bit and make it a little easier so we can talk about some things here. So I'm going to resize this guy. Oh man, don't you like these little pop-up comes? When does it come? I'm going to recenter, drop down one or two, and talk about devices. One more down, maybe. Okay, let me go regain control of the pen here. And let's just talk in general about why can't I get the pen? Okay, this is commentary on schematics. So to understand schematics is that you need to know what goes on in these blocks, and there's a lot going on. This thing is a receiver. This thing is a whole receiver, and this is a whole transmitter. And these things are named, and you can go Google these things and look them up. Now let me just kind of tell you what all these devices do. This is a switch. We've talked about that, and it can be modeled by just a plain old physical switch. And the voltages on this side and this side control this thing. So a high here and a low here will make this switch do this. If you put a low here and a high here, it'll make this switch do this. So this is just a plain old switch. It's a solid state switch. This device here, let's talk about this thing. This is simply a FET, a dual FET, and it's an N-type FET. And of course we model it a simple FET like this, and I'm having trouble drawing it, where this is the drain, and this is the source, and this is the gate. And this is an N-type FET, and to make this device conduct, we have to drive the gate about 2.5 volts above the drain. So the drain has got sitting over here at about 3 volts. So we want to drive this thing at about 7 volts. Well, this device here is what we call a high side driver, and what comes in here is digital signals. So somewhere along the line, this signal is going to be high or low, either 0 or 3 volts. So if you put 3 volts on the input, this drives this gate signal to 7 volts. That 7 volts drives a gate over here, which controls some current. The nice thing about FETs is that when they're in the on state, they can pass amps with only a 100 or so millivolts drop. So this here's what's in this receiver. Or in the low speed modem, the COM daughter board of the low speed modem is that there's a transmitter, there's a receiver, there's several of these RF switches, there's a high side driver, and there's a FET switch. And of course these are just FETs that are going to drive some LEDs in here. So so in general, that's it. This is what's on the COM board, and the COM daughter board, and I encourage you to watch both videos. See you so long till next time.